Howdy folks, welcome back to another CS 120 Honors lecture. In today's lecture, we're going to cover pattern matching in Rust. So our goals for today are as follows. First, we'll briefly introduce two different types of strings in Rust, and then we'll go in depth into match statements and walk through some examples of them. So first, let's talk about two different types of strings in Rust. There are many different types of strings, however, these are the only ones we'll be covering in this course. So first, there's the ampersand str, also known as the string slice, and then there's the capital S string type. In the future, we'll have a dedicated lecture on what the difference between these two types are, since this will be much more clear once we cover Rust's memory management system. However, for now, I just want to give you an interface to interact with these two types, since they'll appear in your MPs and homework assignments coming up. For now, the biggest difference you should know between the two types is that string slices are immutable, while the capital S strings are mutable. This means that in general, you can modify or add to a variable of type capital S string, but not of type string slice. Both of these types, however, have functions to parse them. You can extract substrings from them, and you can also split them, etc. You can find all of these functions or methods in the documentation. Simply just Google string slices in Rust or strings in Rust or something along those lines. So to create strings, it's a little different for the two types. For string slices, it's very simple. Just type out the string you want, surrounded by double quotes. So in our example, we created a new string slice, hello CS 128 honors, and then we binded that to the variable s. For a capital S string, you have a few different ways of creating these. You can use the from method and pass a string slice as the argument. You can also convert a string slice to a capital S string using the doString method. You can also create an empty string using the new method or constructor. And finally, if you want to convert variables or values of numeric type, or maybe some other type, you can use the toString method. So now to convert between the two, if you want to go from a string to a string slice, you can use the asStir method. So in our example, you can see that we created a capital S string using the from method, and then we converted that to a string slice using the asStir method. There are a couple of other ways to do this, such as borrowing the string or using the deref method. However, I believe those techniques will make much more sense after we cover memory management, so we can talk about them in a later lecture. Now, to convert from a string slice to a capital S string, you can use either of the aforementioned toString method or the from method to do this. So now onto the match keyword. Matching allows you to compare a value against a series of patterns, and then you can execute code based on which pattern matches. We'll look at some patterns in the next slide, but these patterns can be made up of pretty much anything, such as literal values, variable names, things called wildcards, and many other things are valid patterns. You may be familiar with a similar construct called switch statements, which is found in many other programming languages such as Java or Python. Match statements are pretty much just switch statements on steroids. So let's look at an example. In this example, we have a function called getCourseNumber, which we can assume for now returns a random integer, and we'll let the course variable equal that integer. And then we're going to use a match statement to match that course number to a pattern in the match statement. So if we look at our match statement, when this is executed, it will compare the course value to each of the patterns in its 5 arms. In this pattern, or in this example, the patterns are simply integers. since the value we are trying to match is also an integer. So let's say, for example, our course variable was the value 173. When this match statement executes, it will check to see if the first pattern matches course. Since the first pattern is 124, it doesn't match course. So we'll move on to the next pattern, which is 128, which also doesn't match course. So we'll move on to the third pattern, which is 173, and that does match course. So since this matches, the code associated with this arm in the match statement, so the code on the right-hand side of the arrow in the arm, will get executed. For this example, since the code is simply a string slice, the string slice will be returned for the entire match statement or expression, and will bind that return value to the professor variable. And then that'll be used down here to print the string. You might notice that one of these arms or patterns is not quite like the others. In the last arm, there's an underscore instead of an integer for the pattern. This is known as the catch-all pattern or the wildcard. Match statements in Rust must be exhaustive, which means that the match statement must exhaust every last possibility in order for the code to be valid. So in our example, let's say that the course number was 374. If we look at our match statement, we have no arm or pattern that directly matches the 374 value. So one way to solve this would be to simply add another arm with a pattern that is 374. However, if we started doing this for every single possible integer, it would simply become impossible. So instead, we can have a catch-all pattern. The catch-all patterns use a special pattern called a wildcard or an underscore that matches any remaining value. So in our example, since there's no 374 arm, the 374 value in course would match to the wildcard, and the string slice, I don't know who, would be returned. Okay, so let's go over a brief demo and check out the course number example in action. So in our main.rs file, we've got our main function. And inside our main function, we first bind the return value of getCourseNumber to this course variable. The getCourseNumber function can be found down here. It uses the rand crate to randomly pick a course from this local array, and then it returns that. After we bind that return value to course, we then bind the result of this match statement to professor. And then we use the professor and course variables to format this string and print it. So let's try running that. Okay, so it looks like getCourseNumber returned 128. So our match statement up here enters the second arm and it returns Professor Nowak, which is then printed as we see here. Professor Nowak teaches CS 128. So now let's try a value that isn't covered in our match arms. So I'm going to change this return value of getCourseNumber to 374. So then when our match statement is executed, we'll enter this wildcard case because 374 doesn't match any of the patterns above. And then it'll print out, I don't know who teaches CS 374. So we can check that if we run it. And we can see that it printed exactly what we thought it would print. I don't know who teaches CS 374. Okay, now we're going to talk about one of the more advanced features of match statements called destructuring. If the type we are matching can be decomposed, so things like tuples, Then we can pick and choose specific parts of that type to match. We can use the wildcard, the underscore, to indicate which parts of the data type we don't care about matching. So we do not care about what is in that part of the data type. We only care about what's in the other parts. We can use the range notation, which is 2 periods, to indicate that we do not care about matching a portion that the range covers in the data type. So let's say we only care about the first value in a tuple. We can specify the first value that we are trying to match. And then we can use the 2 periods to say that we don't care about what appears after that first value in the tuple. We can also use variables like wildcards because they do cover the remaining patterns. However, when we use a variable instead of just an underscore, we're indicating that we still do care about the particular part of the data type, and we want to use it sometime in the future. So we're binding it to a variable. So let's look at an example where we're trying to match some tuple of 3 integers. Starting with the first arm, we're using a wildcard to say that we don't care about the first value in the triple. We'd be okay with anything as long as the last 2 values are 2 and 3 respectively. In the second arm, we're using the range notation to specify that we only care about the first value. So we are looking for 128 in the first position, and we don't care what comes after it in the last 2 positions of the tuple. The third arm is very similar. However, for this one, we don't care about what comes in the first 2 positions of the tuple. We only care that the last item is 2002. In the fourth arm, we're doing variable binding. This variable x is not a pattern. It's functioning as a wildcard. So if this tuple has 1 and 1 in its last 2 positions, it will match this pattern regardless of what's in the first spot. However, unlike just using a underscore for the wildcard, we're using the variable x so we can keep track of what's in the first value of this tuple, so we can print it in the expression of this arm. And finally, this last arm acts as our catch-all. It will match any tuple since the variables in this pattern act as wildcards. Okay, awesome. So that's all for today. Just some quick reminders. Homework 1 has been released and it's due next Monday. Homework 2 and MP0 have also been released today, and they're due September 13th and September 20th, respectively. Okay, great. That's all. I'll see you guys next week.